Good afternoon, everyone. Happy to have you all back here on a Friday. Christopher Crane is not here today, so I will be flying solo once again. That's okay. I've got some stuff planned for us today to kind of go over. So I figured what I would do is just kind of start at the beginning where we kind of left off. Just a quick recap on what we did on Monday. So we'll kind of just jump through these initial slides, kind of just explain what FeatureCAM is and what it's for and how it works. I did a quick AFR demo, quick overview of FeatureCAM and how FeatureCAM kind of provides the power mill solution on the surface milling side. Quick overview of roughing, different options for roughing, Z-level, plunge, parallel, different options. These are the different looks in a bird eye view of the offset types. Just recap the first hour of the webinar from Monday if you'd like to watch that, familiarize yourself with it. So some other options for when you're roughing, just things to consider like step cutting. It's a nice way to remove the excess amount of stock from your larger depths of cut. It just remachines back up to the previous depth of cut. Area removal just removes any type of basically areas that you don't want the tool to enter into because you could damage the non-cutting portion of the tool, like the indexing portion of the tool. And then stock models are a good tool to reference previous or your next toolpath to previous operations. Okay, so with that being said, let's just kind of jump into some finishing options for FeatureCAM. So normally every CAM system has their traditional type of CAM toolpaths, like your favorites, your go-tos. Same thing with FeatureCAM. These are the ones that I kind of suggest if you're just getting into it. These are the ones that I would suggest kind of jumping into or looking into first. So parallel. Every CAM system has something like parallel, zigzag, linear passes. So basically what this does is that the tool tracks in parallel passes against the model. We can change the angle. There's different options there. We'll go through an example of parallel. Z-level, it's the same as what we did in the roughing side with Z-level on Monday, except all the excess amount of material has already been removed. So there's no need to remove that material anymore. So it's we're just finishing a minimal amount of material. And then we also have the 3D spiral option, which to me is probably the easiest toolpath to lay against your model. It collapses in or out. There's some options there for finishing, but if you're just new to CAM in general, I would suggest probably starting with this one first because it's just a really simple toolpath to understand. Okay, apologize about that. That should have came earlier. On the opposing side to finishing strategies over here, we've got specialized strategies, more fine-tuned strategies. So what you're gonna kind of see here is depending on your indexing option. So if you've got to set the 3-axis only, you're probably not gonna see something like 4th-axis rotary or 5-axis trim. If you're in 5-axis mode, you're gonna see 5-axis trim, maybe not 4th axis until you turn on 4th axis, then you're gonna see rotary. So it really depends on your kind of your setup options within FeatureCAM itself as to what strategies you can use over here. But kind of the ones that I kind of lean on the most because I think they're probably very important to understand. First is steep and shallow. So if you go back to the common toolpaths that we were just talking about, steep and shallow kind of mixes those toolpaths together to create some kind of like a hybrid type toolpath. So it's really great tool to use when you've got some kind of complex geometry you need to remove the material or create a nice finish pass on. So it leaves a lot of the guessing work out and basically eliminating areas with boundaries and whatnot, because this will just finish all areas. And we have the control to dictate what's steep and shallow based on a threshold angle. Corner finishing, it's kind of the same as what we're talking about out here. I mean, if I want to attack certain regions of my part, in this case, corners or fillets, This just allows me to basically enter some information into FeatureCAM as to what the previous tool was, and it's only going to look in those areas that are smaller than that diameter or that radius. We'll go through an example of that one as well. And then Swarf, I think is probably the easiest toolpath to go from 3-axis to simultaneous live 5, because really all you're doing is picking a surface, and the software does majority of the rest, because the tool, the end mill, the side of the tool is going to lay against that surface. So it's really the important aspects of this toolpath are that you have good swarfable surfaces. So it's got to be nice and ruled, like flat planar surfaces. Doesn't have to be vertical, but they just need to be nice planar surfaces. So if you get really bad results when you use Swarf, it's most likely because the surface data is not good. Okay, so we'll leave this slide here. We'll jump into FeatureCAM, and we'll kind of take a look at what we looked at on Monday. Carry on with this part. So we calculated these 3 toolpaths Monday: roughing strategies, a main rougher, remachine with a smaller tool, and then we ran a parallel over top just to remove a lot of the cusps in the bottom of the part. And remember, we used a stock model to kind of visualize what our part looks like at this point in time. And the stock model is also a great tool to refer a subsequent operation on. So if I wanted to go in with a smaller tool in these corners, I can use the stock model to tell FeatureCAM where the remaining stock is, only cut those areas. Another great tool that we have, if I were to just do a 3D sim here and hit play, and I'm going to just make sure it simulates pretty quick. These are the same toolpaths we ran on Monday. So one thing I'm going to do is just store the results starting point. And then lastly, what I'm going to do, as a programmer, I want to know where all the excess amount of stock is. So what I could do is go into the solid tree down here, right click on my part. And right now the checkbox or the imprint next to the option of use solid as part compare target is turned on. So you just click on it. And then once I run my 3D sim, I can jump up into the show options and show a part compare. And now what FeatureCAM is going to do is show me anywhere where the excess amount of material lies. So green is finished, blue is excess. I think is anything over 2000s by default. The options to change this are up in the FeatureCAM options. Okay, so let's just eject that real quick and kind of carry on with jumping into some finishing passes. So as I mentioned, probably the easiest toolpath to throw down, I like using it for semi-finish, would be to use a 3D spiral. So what I'm going to do is use the select by color option, and I'm going to select all the orange surfaces, as well as these 3 top surfaces and this cover that we created on Monday. I'm going to jump up to Features, Surface Milling, and I'm going to add these into my part tree. A single operation, 3D spiral. So the offsets are consistent as it tracks down inside the model. If I was working on a flat planar surface, then 2D spiral would do the trick. Okay, so I'm just going to turn on continuous spiral. This is kind of the same option we talked about in roughing, where it's going to continually spiral inwards in a continuous segment unless it needs to break itself off to move to the next area. And I'm going to turn on smoothing, which allows, when I'm transitioning maybe in an X move to a Y move, it's going to put a nice arc fillet there. Okay, so let's just go ahead and hit finish. And the first thing I'm going to do is I'm just going to make sure I got the right tool selected. So 1/2 inch ball, I'm going to go ahead and select the 3/8 ball. I'm going to jump into my milling tab, and I'm going to change the step over to something slightly smaller, 25 thousandths. And what I'm going to do is change the leave allowance. Since I'm semi-finishing, maybe I want to leave 10 thousandths. And apply. And I'm going to do a quick preview just to see what the part looks like in Centerline Sim. And if everything looks good in Centerline Sim, then I'll continue on with my next strategy. And just so you're aware, surface milling, especially when you get into finishing in 5-axis, they do take a little bit longer to calculate. So you can see as the thing tracks, it's doing a single type of segment all the way down to the center of my part. And if we zoom in here, we can see these nice transition moves for smoothing from the X to the Y move. Okay, so I'm pretty happy with that. So I'm going to eject, and I'm going to hit OK. And then maybe the next toolpath, I'm going to cut these flats. Okay, so I'm going to go ahead and select them, just like we selected the part previously. Select these three surfaces, jump up to feature creation, surface milling, add these three faces, single operation, and I'm going to use a 2D spiral just to finish these flats. And I'm going to spiral inwards. And what I'm going to do is just finish once again. And I'm going to go ahead and use a flat a flat end mill. And maybe I'll use a 1/2-inch end mill, the default. Oh, that's the ball nose. Sorry, let's go back and find a 1/2-inch flat. There we go. Okay, so let's just do a quick preview. This one should calculate a little bit quicker than the previous. Okay, so not bad. The only thing is a little trick here. If I want to kind of start on the outside and work my way in, this is where we can kind of play around with some of the edge control. So the edge control, I'm going to turn it to cut top edge, just roll over. Again, once I change something, I like doing a preview, even though it might take 20 seconds or so. It saves me a lot of time from turning on a lot of options and not understanding what's happened. So everything looks good except for around these fillet regions. And that's kind of happens because we got the edge of the tool, which is a flat end mill, and then we've got these vertical walls, which are straight. And sometimes since they're bang onto each other, we're going to get the toolpath kind of falling towards the bottom. Could be a tolerance issue. So kind of to rectify that, what I'm going to do is jump into the finishing milling tab. And again, leave allowance. I'm going to change the leave allowance here to something a little bit larger, like maybe 50 thousandths. And then the axial leave allowance, I'm going to bring this to 0. So when you change the leave allowance here, you also have the option of overriding the axial, which is going to be the Z. So I'm going to have two different types of allowance. So this is going to be more or less side stock, and this is going to be more or less Z stock. And I'm going to jump into my leads here. I'm going to change this on to loop. So when it transitions from offset to offset, it's going to have a nice high-speed motion there. And as we're talking about this, I'm going to jump back into the milling tab. And toolpath corner, I'm going to change this to 10% of my tool. Let's do another preview. As you get more comfortable with creating these strategies, you're going to kind of know which ones to turn on and off. But if we kind of zoom in here, we can see nice fillets instead of having those hard transition moves. And we're starting outside the part and we're working our way in. So if I were to simulate this point to point, we're starting somewhat off the model and we're going to work our way in. It should leave a better surface finish. Okay, so let's eject that and we're going to hit OK. And maybe what I'll do is just rename these so I know exactly what there are. 3D spiral semi. And this one, maybe I'll call it finish top flats. And OK. All right, then maybe what I'll do is I'll just carry on with running a 3D sim from where we were before. I'm just going to do a single step to step into the sim. Since I've got the slider bar all the way to the right-hand side, I want to control that a little bit. Okay, and let's just go ahead and play this forward. My mistake. Let's turn these off. I don't need to rerun those. There we go. That makes things easier to watch. So there's all the semi-stock being removed. Now we're leaving 10 thou globally, which is on the radial and axial stock. And then we should be finishing the top flat straight to 0. So it should be roughly taking about 40 thousandths worth of stock off those faces, and then we've got our finish on the top. Okay. And then what we could do again is just show part compare, which if everything goes correctly, which I would probably need to rerun all the sim. Apologize about that. Let's just play this forward again real quick. Okay, there's the top flats. Let's do a part compare. And for whatever reason, it's not behaving correctly. I'm not quite sure. I think I have to clear the results and then run the sim once again. So let me just do that one more time. Let's run this fast forward. Okay, so after the sim, fingers crossed, part compare, there we go. Okay, so we still have excess amount of stock in the part, but we can see that since we ran the finish on the top flats, it's giving me the indication that there is no stock left on the top flats there. So let's eject that. And let's kind of carry on. So instead of programming this part completely, what I've done is in another session of FeatureCAM, I programmed this part with different type of strategies. We'll just kind of go through it with those pre-calculated toolpaths, and we'll kind of just talk our way through some of the options. So let's jump into that finished FeatureCAM session here. Okay, so 3D spiral, which we just looked at, and then the finished flats. Let's kind of carry on with that. So kind of what I wanted to talk about is this pocket down here. So if I just select this surface, do a Control J to blank that surface, let's look at this pocket. So this is where it's nice to have a mixture of 2.5D toolpath and a 3D type toolpath, because I have the choice. And you can see here I've got 2 different strategies that attack this region. Let's go ahead and just kind of look at each option here. So let's go into properties. So what Z level does is I'm going to select the surfaces that I want to machine, which in this case is this pocket. And Z level is just going to track the tool against the vertical walls of the surface. So it's almost like a 2D side pocket, or a 2D side or a pocket. Okay, so I've already gone ahead, picked the tool, picked my step downs, changed some of the pertinent information like my leads and links. If I do a quick preview, okay, so you can see how the tool tracks around this pocket against the wall until it hits that flat and it finishes. Now that's one toolpath though, and that's just a straight finishing toolpath. So with surface milling, I have to be very strategic if I want to remove material before I'm like a semi operation. So what I might have to do is actually create 2 toolpaths, one for semi and then one for finishing. Whereas if I do what we would normally do in a 2.5D type strategy, maybe do an IFR or an AFR to find this pocket. So you can run AFR, or I can run a pocket extracted with feature recognition, and it should find that pocket, which it does. So I've already gone ahead and done that. And with that pocket recognition, what I've done is just run a finishing strategy with 2.5D. And there is an option to turn on semi-finish or roughing. And it's basically the same type of strategy, except I'm taking a little bit smaller step down, that's all. So that's the nice thing about FeatureCAM, gives you a couple multiple different ways of kind of performing the same task. Okay, so I'm going to use the 2.5D pocket option, but Z level is also a viable option. So let's kind of look at parallel type strategy. So let's go into the properties of parallel. And what is parallel exactly? Well, parallel is the same type of parallel we looked at in the roughing strategy, where I can pick the direction of travel, which in this case, we're going to move in the X direction, 0 degrees. I do have the option of changing the angle. If I were to select parallel at 0, the tool will be tracking up and down in the Y. So I've got multiple options, or I can just turn on automatic and just have FeatureCAM kind of find the best situation for me. So I'm going to leave it on X parallel. We're finishing. So I'm going to machine this to 0 stock. I've already gone ahead and changed the type of options. So if I were to jump in the finish 1, go into milling, I've already changed my step overs, perhaps tolerance. Let's jump back into parallel real quick. Let's do a quick preview and play. Okay, so you can see how the tool tracks back and forth in a linear type fashion. And I'm just going to play this simulation a little bit quicker here, and I'll kind of explain what is happening here. So it skips this region. That's because in parallel, we can actually do kind of like a hybrid type operation. So when we get into these regions where we don't want the side of the tool to cut these steeper regions, we can cut those out and replace it with a perpendicular pass. So that's located here. If I were to remove these and hit apply and preview, you'll kind of see the difference here. So it's going to track across, and in that region, we're going to cut more on the side of the tool, which is something that we really strive to remove or avoid. So there's a few different options here with the parallel that you have access to. So parallel in most other CAM systems are pretty dumb, if you will, but with FeatureCAM, it gives you that intelligence where you can change the angle and have FeatureCAM kind of track in a perpendicular pass in those unwanted segments or unwanted regions. We also have, if I were to jump into this option here, all of the 3D type strategies, we have options of controlling the points. So out of the box, you should get a pretty decent surface finish, but if you want that optimal surface finish, we can jump into, the finish underneath the milling tab. We can go into the output options and really tighten or add the amount of points. So if I were to do a preview, it is going to recalculate itself. But we're cutting this other opposing side. If we look, we can see the amount of points that I've added to this toolpath, which is going to give me a much better surface control or surface finish. Okay, so let's just hit OK on that. Let's do a quick preview. And by naked eye, you're not going to see it really too much in the preview side, but I left the other options on in this toolpath like we did on the other side of the part. Okay, so it's going back, adding that perpendicular pass or optimized. And there we go. Okay, that's just one option. If I were finishing this part, as I was mentioning in the slides earlier in my PowerPoint, in the specialized strategies, we also have a really nice strategy to finish these complex type shapes, and that would be steep and shallow. So let's just hit OK on this. And let's take a look at steep and shallow if we go into the preview. And I've already got this toolpath, the options kind of turned on, but if we do a preview of this toolpath, you'll kind of get an idea of what it's doing. So all the steep regions, which should be more or less on the vertical walls, FeatureCAM is going to basically do a Z level, like we talked about, like what happens in these pockets. And then on all the shallow regions, we can replace the shallow region with either a parallel pass or we can do a 3D spiral. We have that choice. So if we were to jump into the properties of this strategy real quick, if we jump into the main steep and shallow page, this is where we can dictate the threshold angle. We can give it an overlap, so like a blend distance. We've got options for continuous spiral. If I was working in a closed area or closed pocket, I can use continuous spiral to keep that tool spiraling from the top down. And then we also have in the shallow regions, which would be more or less down here in the bottom, we have the option of dictating if we want that parallel or that 3D spiral, which we already looked at previously. So it gives you a lot of flexibility. And we also have, in case you weren't aware, if we jump over to the leads page, we also have the methods on controlling the way it transitions once it leaves the part. So if I kind of just zoom in to this region here and rotate that around, we can see that we've got this arc move, which is here. Arc moves off, and then it drops down, and then arc moves back onto the part. So this is all controlled in the leads page. One thing I notice is this direct move. Well, if I wanted to do maybe like a loop, let's do a preview. Let's recalculate that toolpath. It won't take too long. So now you can see that nice arc move to transition with the arc move off. So it really depends on your flavor and what you prefer. Okay, so I'm going to turn off these two parallel passes. I'm going to prefer using steep and shallow. Let's go ahead, I'm going to shut these two off right now. Let's go ahead and run a 3D sim. Oh, let's eject out of that. Okay, let's run a 3D sim. Let's turn all these guys back on. Finish the flats. Let's do a 2D pocket, and then we'll run the steep and shallow. Okay, I'm just going to speed this up, especially the first few strategies here until we get to the pocket and the steep and shallow. Okay, so there's our semi-finish. Then we're going to cut the flats after the semi, and then we'll go into that pocket and the finish pass. So there's our finish operation. I'm using a 1/4 inch ball. So it always works its way from the top to the bottom, which is a nice, safe, efficient toolpath in a contained area. So the nice thing about running a 3D sim is that if I had any gouges or any type of collisions with the holder or the shank, it would pause and let me know if I have that option turned on. Okay, so it looks pretty good. What I'm gonna do is just save the results. Actually, let's do a part compare real quick. So we can see we've got a little bit of stock in these radiuses. Let's go ahead and eject that. So let's take care of those corners. No need to run the simulation any longer. So let's just turn everything off and kind of let's focus on these corners here. So another strategic or specialized strategy we can run are strictly on corners. And let's go ahead and look at the properties here. And we would pick the surfaces the same method. Pick the surfaces on a machine. And with corner finishing, what we're going to do is pick the option. So there's multiple different options that we can utilize. Multi-pencil, combo along and across is my favorite, but for this, I'm going to use multi-pencil. I'm going to leave the default. What we need to do is tell FeatureCAM what the last tool, the last cutter was, which in this case is a 1/4-inch ball nose tool. And then we're going to add a little bit of overcut just for blend purposes. So let's do a preview on this, kind of show you what this does. Okay, so you can see how it only strictly goes into the corners. And we're going from a 1/4 inch to a 1/8. Okay, let's eject that. I'm gonna hit OK real quick. Let's just give you 1 second. I'm just gonna turn something off here. So no multi-axis, let's go OK. And I'm actually gonna turn on all these strategies once again. So spiral, fin flats, 2D pocket, steep and shallow, and then the corner finishing. And I'm just gonna run a 3D sim, and I'm gonna run it pretty quick here. Okay, so there's our corner finishing. And looks good. So I'm just gonna go ahead and store that as simulation results. And let's go look at a part compare. And we can see we've got still a little bit of extra stock in these corner regions. So we might have to go with a smaller tool. If I don't know what size these fillets are, these radiuses, I'm just gonna do a Control R to refresh my graphics. Let's go up to construct. Let's do curvature. Let's select that fillet. And it looks like it's 1 mil radius there. So we'll have to go in with probably at least a 2 mil ball. Okay. So let's go ahead and take a look at this last toolpath, which is the same toolpath we just looked at with a smaller tool. I'm just going to go ahead and run the 3D sim once again to kind of just step this through. Okay, so we can see the tool. If we hit play, there's the smaller tool getting that stock out. Now, if we kind of just pause, we can see that, let's play that through again. We can see that maybe the tool is having some issues here because of the reach. Looks like we've got a gouge. So this is where, let's eject. You know, we want to keep that tool nice and short. This is where we can get into some of the 5-axis options in FeatureCAM. So if we were to jump into this strategy and this properties here, I'm going to jump into finish. Right now we have no 5-axis control because I just turned it off. But if we were to jump into 5-axis mode, let's turn this on and jump back into the strategy. So we now should have a 5-axis page. This is where we can turn on items like automatic gouge avoidance, or we can change the type of tool axis motion. So we've strictly used vertical or 3-axis since Monday. Let's go ahead and close this. And I'm not going to turn it on in this instance because it really adds to calculation time. So let's just jump back into the PowerPoint real quick. And what I mean by automatic collision avoidance is that right now we've got vertical set. What we could do is turn on an option here to automatically tilt the tool when there's a collision. It's probably the easiest way that you can grasp onto a simultaneous or live 5. Okay, only problem is it leads to excess or long calculation times. So let's jump back into FeatureCAM real quick. I'm going to jump into this exercise, and I've got collision avoidance turned on here. Let's go look at it from the front. I'm going to go ahead and hit play. Okay, so let's just go ahead and step that through. So as it simulates, we can see the gouge. Let's eject that real quick. Let's jump into the properties. Let's go into the 5-axis page, and I'm going to turn on a lead option. So when there's a collision, I want you to lead away from the collision. Okay, so there's a little bit excess amount of calculation once again. Okay, so you can see the collision's already been avoided. Coming up the wall, and the nice thing is that when there's no more collision avoidance, the tool axis is going to go back to vertical. Okay, so it comes down, gets out of the collision, back to vertical, and so on and so forth. So the nice thing about collision avoidance is that I can avoid collisions by different methods. So if I just eject out, hit OK. Oh, let's go back into the options there. In the 5-axis page, avoiding collisions, I've got multiple ways I can avoid collisions. We can get onto a long-winded way here of how we can avoid collisions, but I'm just going to kind of leave it as is right now. If you want more information on maybe some of the tool axis motion, which I was kind of planning on going through, but I don't think we're gonna have a lot of time to kind of capture everything here. So maybe I'll save that for a future webinar. So right now we're just gonna kind of stop at this point in time, and we'll leave this for any Q&A, and we'll go from there. So I'm just gonna hit OK on that. Let's kind of jump back into the PowerPoint, and let's go into the next page. So when avoiding a collision, so there's multiple courses of action here when there's a collision or a gouge in FeatureCAM. You know, we've got different options here. You see I've applied a lead method, but there's 7 or 8 different methods below. Or instead of just avoiding a collision, we could just jump into a multi-axis tool axis right off the get-go, and we can kind of pick the same options here. So again, we'll leave this for a future webinar topic. We'll kind of dive into this a little bit. But we'll leave this as is for now. Okay, and if you're curious about other pieces of the Autodesk Advanced Manufacturing portfolio, these are the products that we have access to, and most of the products here that SolidCAD can support. So FeatureCAM is what we were looking at the last couple of sessions here. We also have PartMaker, which is actually bundled with FeatureCAM. So if you were to buy FeatureCAM, you also get PartMaker, which is a tool for controlling your Swiss lathe. And it also has tools for driving most of these options over here as well. So you get quite a bit of control in here. And then you also have Fusion 360, which is an integrated CAD/CAM engineering software. So if you haven't seen Fusion, I highly recommend just doing a Google search and checking it out, because it's a tool that seems to be getting more powerful as the days go by. Then we also have PowerMill, which is the expert CAM system in my mind when it comes to industry expertise, when it comes to the 5-axis control, unique solutions for blisks and ports or blades, additive and subtractive toolpaths, and it can also drive industrial robots. PowerShape would be more or less PowerMill's complement for drawing complex parts, tool mold tools or mold and die tools, electrode design, and so on and so forth. Inspect, which would be the metrology side. So if I'm doing an inspection with a manual arm or on my CNC mill, this would be the software for that tool. And Fusion also has some of these tools built directly in it, as well as some of the tools that are over here directly embedded into Fusion 360. And then below that, we have NetFab and TrueNest, which 3D printing, and TrueNest is more or less nesting control. So if anything suits your needs and you need some more information on any of these products, feel free to reach out and we can dive into it a little bit deeper. But with that being said, what I'll do is I'll kind of just hang back here, and if there are any questions, we'll just kind of answer them as we go. So I'll just kind of put myself on mute, and if I hear anything or see anything, I'll go ahead and answer. Thanks for everyone for showing up today. If I don't hear any questions pop by, have yourself a great weekend, okay? Thank you.